All right, welcome back. Today we're going to be doing the GI pathway and the GQ pathway. So yesterday, or the previous video, whenever you watch it, if you do watch it, we went over the GS pathway, and that's right over here. And this is the CAMP pathway. This pathway generates CAMP, and we get cell response, right? So something in the cell happens. In the GI pathway, we're doing the exact opposite. So GI, I like to say that the I stands for inhibitor. This is the CAMP inhibitor pathway, meaning we're not going to make any CAMP. This is probably the easiest pathway you'll learn in physiology. Unfortunately, it gets harder from there, so enjoy it while you can. So first step, we get a ligand that binds to the GPCR. This GPCR is special. It's an inhibitory receptor. So unlike the GS pathway here, this GPCR, when activated, right, it activates G protein, which is the red thing. And here, the G protein's deactivating when this ligand binds. So the special type of inhibitor, a special type of receptor rather, and it deactivates the G protein. In turn, this turns off adenyl cyclase. Right, in the GS pathway, when G protein is turned on, adenyl cyclase is turned on. It's like the factory. Adenyl cyclase is the factory, so when G protein is off or deactivated, the factory turns off. Adenyl cyclase shuts down. We're not making CAMP. So ATP is not being converted to CAMP. And that's it. That's literally it. It's so simple. But it's very important to know. All right, now the GQ pathway. So if you're wondering what these pathways actually do, that's going to be in a later video because it's going to be very important for the heart and sympathetic system and that kind of stuff, like fight or flight response. Very important for that, and we're going to go over it. But just for now, just understand what the pathways are. I don't want to overload you with information. All right, the GQ pathway. Why is it Q? I have no idea. It probably stands for something, but it's okay. You don't need to know that. This is also known as the PKC pathway or the protein kinase C pathway. In the GS pathway, we have protein kinase A. Now we have protein kinase C, not protein kinase A in this pathway. Is there a protein kinase B? I don't know. It may be in some pathway, but not the ones we're going to be talking about. So yeah, what's the goal? We're going to phosphorylate proteins, just like the GS pathway, but we're also going to release calcium, which is super important for muscle contractions. So that's a little hint of what this is for. It's for muscle contractions mainly. So we start out, like usual, we have a ligand, which is the green thing that binds to the GPCR receptor. It activates the G protein. Okay, this is when it changes from the GS. We are going to activate phospholipase C. It's an enzyme. Okay? A membrane phospholipid, so a phospholipid from the membrane is going to combine with this enzyme. And two things are going to happen. The first thing that's going to happen, it's going to create something called DAG. I am going to be completely honest with you. I always butcher this name right here. That's the name for DAG, so I'm not going to say it and embarrass myself, but you can try yourself. I always mess it up, and I'm not going to say it, but yes, DAG, that's all you really need to know. There's no way on a test they're going to say, oh, write the full name. Like, that's stupid. Just know the abbreviation, right? DAG. DAG then activates PKC, protein kinase C, like we just said about, a little earlier. Instead of protein kinase A, it's protein kinase C. It is the same thing. A kinase phosphorylates stuff, and protein kinase phosphorylates proteins, and that's exactly where we get phosphorylate proteins. Ta-da! And this causes a cell response. Okay, now let's go back to the second pathway over here, the second branching off. So when membrane phospholipid combines with PLC, It also creates IP3, or inositol triphosphate. What is this going to do? So inositol triphosphate, or IP3, which you just need to know is the abbreviation, it goes over to the endoplasmic reticulum of the cell. Okay, and in the ER, right? In the ER, there's calcium. Think about like a storage unit. The ER is essentially a storage unit, and inside that storage unit is calcium. So imagine if you ever watched that TV show Storage Wars, right? And then they bid on the stuff for the storage units, and they open up the storage units. Imagine the only thing they find is calcium, and calcium is super valuable to you. Calcium is the reason you're able to move and function. Actually, you would not live without calcium. That's how all the muscle contractions happen. Okay, so what IP3 is going to do is going to go over the ER, and it's going to cause calcium to be released from the ER. And this is going to cause a cell response. So calcium is also known, this is very, very important, it's called a second messenger. Okay? The reason it's called a second messenger, right, is that we just have this entire pathway that does so many things, but calcium is further below and still causes a cell response. I know it's very kind of weird to explain it like that. I was trying to think of a different way to explain it, but just think about there's primary ways, which we talked about here, right? We have primary ways, which is just one step. This is essentially like two steps, and that's why it's like a second messenger. What I mean by one step is we had like voltage gated, right? Voltage gated channels. We had hormones that immediately do something, right? Pressure immediately does something. We got a cell response, right? One step, cell response. This is not three steps. I'm saying this is a step by itself. This is a step by itself. This is a step by itself, right? And it causes the cell response. This is in my previous video, so you can go and check that out if you want. So these two things causes a cell response. This pathway is mainly for muscle contraction, which we're going to go over later. All right, that will be it. That will be the GQ pathway. Please like and subscribe, and I'll see you tomorrow. Later.